My name is Panit Jesadawaranon. I'm the vice chairperson for this technical program. So glad to see you all here again. Hope you enjoy the food. So under this challenging environment, we still continue with our mission to keep you informed of what's going on in our industry and make new technology available to you. Tonight we have Kun Simon Hartog over here from RoboTech. He will share us the interesting story on the extreme robot for oil and gas. Our vision is to be open for sharing information with our peer so we can provide energy and sustain our energy in our country. And we also would like to see the smile on your face. And we're glad that we can have this session on face-to-face again. Okay, as usual, our agenda, we will start with the section announcement. And then continue with the presentation from Kun Simon. And then after the presentation, we will have a Q&A session. And also tonight, again, we also have this session on live. So there will be a live broadcast as well for this session. And then after the Q&A, we'll continue with the closing remark and then lucky draw. Clearly, we need more energy in the country. Hold on. Anh phải tệ bác vào. Tệ lắm chứ mấy.สงสัยอยากเป็นโฮสต์ครับผม Okay, our power is back. Let's continue. So Thailand section membership. Today we have over 500 members, combining up to 59 professional and 264 student members from 4 university student chapters: Chulalongkorn, Suranari, Prenop Songkhla, and Chiang Mai. Not only train, we also get 33 new professionals at the beginning of the year to date. Do note that I always keep the number here. We still have 135 labs. So please renew your membership. And please also invite your colleague to join SPE as well. So SPE Thailand is still the largest professional oil industry organization where you can regularly meet and greet in this relaxing environment. On the topic of SPE membership, there are plenty of reasons you should join. I will not go through it here. But it's worth to mention that again, this is the most active section in Southeast Asia. So this is the opportunity for you to network, to share the knowledge and socialize with your peers with the same interest in our industry. And of course, this tonight would not happen if we do not have our generous sponsor. So may I have applause from the room for our generous sponsor for tonight. And for those who have just joined in this meeting, please, if you want to see your sponsor or your logo up here, please contact to any of board members. And we appreciated your support, and of course, our society needs you. For the speaker introduction, let me hand over to my everlasting boss. Ready, man? Thank you, ครับคุณเกษียณ
You as always. Wow. I think this is the first time I ever get applause. All right. Anyway, thanks for coming. My name is Kasian. I'm the program chair for SPE Thailand. I'm sure you all know me by now. I'm always glad to see the faces every time. It's been challenging, as Kun Panit mentioned, right? In the past month, very difficult to arrange anything, and I'm sure you know, right? We planned to have actual meeting, and it had to be changed to virtual. We planned virtual, things good, we changed to actual. So stay in touch with us, and next month we are going to have a huge one. Basically, we call it the industry reception, where the Director General, Dr. Sarawut, will be telling us on what's happening in the themes, in the upcoming work on the Thailand, also Gulf Thailand especially. Okay? So without further ado, let me start introducing our speaker for this evening. So our speaker is the CEO of RotoTech, PTE Ltd, providing new robotic solutions to the oil and gas industry in the field of splash zones and subsea inspection and repair robotics. Prior to this, our speaker has been president of Pipeline and Piling System Ltd, CEO of Cape Group Ltd, and managing director of ICE Far East. Before this, he was area manager for Fraser Diving Middle East and operations and equipment managers of Taylor Diving SEA. Taylor Diving installed the first PTT pipeline into Thailand in 1981. Simon, our speaker, held the record for the deepest saturation dive performed in Asia for 30 years. Ladies and gentlemen, please a warm welcome to our speaker this evening, Kun Simon Hartog, Managing Director of RotoTech.
Good evening, ladies and gentlemen. I hope you can all hear at the back. Thank you for allowing me to give you this talk to you tonight. I'm not sure of everyone's background, and I see fantastically we've got lots of students here, which is wonderful. So what we're going to see tonight, for some of you may be familiar, and for others it won't be. I hope that the scope is broad enough that there's something for everybody, and that it will bring something of interest to you all. Now, if your glasses are all full, which they should be, then we will start. So tonight's talk is on extreme robots, the benefits and the challenges. When we look at robots, what does it bring to our mind? Well, depending on when you were born, the word robot evokes a myriad of images. It could mean R2-D2 or a dialect from Doctor Who, for those of you that remember that, a cute robot from Star Wars, or a cyborg from the last horror film that you watched. But in today's offshore world, the robots that we use come in all different shapes and sizes. What's driving the development of the use of offshore robots? Well, there's a whole lot of reasons, really. And when I started to do this, it was before the invasion of Ukraine. So the price of oil was rather low, but it isn't anymore. However, when it was rather low, there was a need to reduce costs. And personnel are one of the largest costs that a company can have, because it's not just the salaries, obviously, it's the uniforms, the insurance, the leave, and everything else that's required. Over the years, the people that have been in the industry for years are now retiring, and they're getting out of the industry. And a lot of young people don't want to join the industry, and they don't want to go offshore. Renewables are coming on stream, and renewables are becoming very cheap. So the oil and gas industry has to reduce its costs in order to be able to compete with the renewables. In Thailand, Malaysia, Burma, Indonesia, and many other places in the world, the shallow water oil fields are drying up. They're coming to their end of their life, and people are moving to deeper water. So the use of divers is not possible anymore because the waters are far too deep. So robotics of one sort or another are needed to cope. The young people that are coming into the offshore industry are no longer happy with going offshore for 3 to 6 months, as some of the older ones of us did. They'd like to go offshore for 2 weeks at a time. Well, that means you need more people. It needs more helicopters, more boats, more fuel. It's a much bigger cost. We need to cut our carbon footprint. So in order to do that, we need to reduce those helicopters and vessels and the change-out costs. And then, of course, the offshore industry has always been a dangerous place to be. So for health and safety, the move towards robots is an obvious one. Where do we use these robots? Well, really, we use them everywhere. They're in the air, they're on the platform main deck, on the drill floor, in the splash zone, and they're also used subsea. There's always somewhere where that you can use it. We're probably all familiar with drones. Some of us have them, lucky enough to have them as toys to take pictures with. But they're also known as unmanned aerial vehicles, or UAV. And they come in the 2 types you can see on the screen of minicopters and fixed-wing drones. We might today be familiar with the words predator and reaper and the images that these bring to mind, especially when we look at the photos and videos of the invasion of Ukraine. In the offshore industry, drones have an important role to play. Drones that can stay flying for hours and carry a multitude of different tools, cameras, and sensors are what are needed. And the tasks that these can perform are as diverse as pipeline surveys, gas and oil leak detection, flare stack inspection, corrosion inspection, and photogrammetry of structures. If we look at this picture here, we can see the flare stack here. In order to inspect that without a drone, somebody has to go there with rope access. Before they can get there, the flare has to be switched off. The whole structure has to be allowed to cool down. That means loss of production. And then you have to go up there and inspect it, which is a big HSE risk. By using a drone, you don't have to switch the flare off. You can go and inspect it and look at it, and production can remain happening. We heard about 2 months ago at this SPE Thailand meeting about how detection of gas leaks can be measured from space. With drones, we can use optical gas imaging, or OGI, to detect, visualize, and pinpoint gases such as methane, ethane, propane, butane, and benzene. And after we found these, you can perform a TDLAS, or Turnable Diode Laser Absorption Spectroscopy on it. I think TDLAS is a lot easier. These can be performed to identify and quantify the gas concentration. And this ability to monitor leaks, inspect for corrosion, and measure damage robotically are invaluable for saving time and money rather than perform these same tasks by traditional means. Other things that we could do with drones may vary from the resupply of platforms. That doesn't necessitate a vessel going alongside, which means the risk of collision with the platform is greatly reduced. To rescue missions for people who've fallen overboard, so that their searches can be done with a drone without the hazards of and firefighting tasks without the hazards of putting somebody on the platform. And here we can see a group of platforms all joined together. And from the size of this, you can see that the day-to-day inspection for corrosion and leaks and things is a major task to be done. It would be far better to be able to do that robotically. And the tasks that are needing to be done on every day-to-day basis range from corrosion monitoring to gas and oil leaks and to drilling operations on the drill floor. Platform robots can perform the routine operations of measuring and monitoring corrosion, sampling the air for leaks. Some can also perform even more useful tasks. Let's see what's available today. Well, one type of robot that you've probably seen on YouTube is called Spot. It's a robot dog developed by Boston Dynamics. This has now been refined so that it can recharge itself from its kennel, and it can carry instruments like lasers for measuring, cameras of different types such as low light, infrared, 3D, gas sensors, ultrasonic thickness measuring probes for corrosion mapping, thermal sensors, gauge reading abilities, and even a simple manipulator. A Spot can climb stairs and right itself if it falls over. It's become an asset to platform life. Having so many compatible tools that it can be equipped with makes it more useful, so much so that it can reduce the number of human personnel needed offshore. And that means a reduction in CO2 and less environmental damage. This type of robot is especially practical on unmanned platforms, where the use of the robot greatly adds to the fixed camera systems that are already installed. Spot, though neat, and it's not built for strength. Tracked robots and wheeled robots are also being developed. These can carry much larger manipulators, meaning that valves can be opened or closed, and other such tasks can be performed. Another very useful application for these robots is the ability to enter places where the air is polluted. And this could come from an H2S release, or into rooms where fire suppression systems have been activated and the air is unbreathable. For those of you that haven't been offshore, this next video is a video of the drill floor, of what happens today on an oil rig offshore. So when we refer to extreme robotics, this is where we find extreme robots. It's on the drill floor. The drill floor is the most dangerous place on a platform. It's where the drill pipe is screwed together in long lengths to be attached to the drill tube that's already in the oil well. This is where the drilling mud spills onto the deck of the drilling platform when we break the joints of drill pipe. And because drilling is carried out to thousands of feet below the drill floor and the surface of the earth, when it's time to change the drill bit, the speed of joining or removing the drill pipe needs to be carried out as fast as possible. Due to the mud making the deck slippery, the weight of the drill pipe, speed of the operation, and the size of the equipment being used, together with the always present danger of a blowout or gas discharge, the drill floor is where most accidents happen. On top of these dangers lie natural hazards, such as the cold when drilling in the Arctic, or the heat when drilling in the tropics. And drilling takes place 24 hours a day in the dark as well as the sun, when personnel are just awake or feeling tired, which is when accidents happen. If the drilling could be automated by using robots, this would be a great health and safety step forward. After accidents like the Deepwater Horizon in the Gulf of Mexico, the loss of life on the drill floor, drilling methods need to change. The use of these new roughneck robots is expected to save 40 drilling days per year. This can equate to a saving of up to $12 million US. Robotic operations mean that drilling crews can be reduced. This saves personnel costs, insurance costs, transport costs, and manning costs. And then from a safety aspect, with a robotic drill floor, no personnel need to be in the red zone. Reduced costs in terms of time, a smaller CO2 footprint, safety improvements are all the benefits of adopting robotic solutions. This is the reality today of a fully robotized drilling floor. You can see in here the two drillers are in their cabin there. That's isolated from the air on the drill floor, so if there was a blowout or there was a gas discharge, they're safe. There's absolutely nobody near where you're taking the drill string out, you're joining it, you're torquing it up. It's a much, much safer environment. Subsea robots. There are many different tasks to be performed subsea, and some have traditionally been carried out by divers. But now that the oil and gas industry is moving to deeper waters, divers basically can't go deeper than about 1,000 feet, although the record is about 2,002 feet. ROVs, or robots, are a much better way of doing things. When used subsea, these are referred to mostly as remotely operated vehicles, or ROVs. But today, they're now called autonomous underwater vehicles, or AUV. A traditional ROV is operated via a wire, or a tether, as it's called. And this connects the ROV to its control console and its power supply. When used in deep water or in high currents, the tether causes drag on the remotely operated vehicle. The longer the tether, the more drag this puts on the robot. In turn, this reduces its range. In deeper water, in order to use short tethers, the ROV operates from a garage with what's called a tether management system, where the tether is coiled up and released as the ROV needs it. This makes the system more complicated, and simplicity is the key to good robotics. In order to overcome this problem and also to be able to perform tasks such as pipeline surveys, a new type of robot was conceived called the AUV. We're probably most familiar with AUVs through the search for the lost aeroplane MH370, which was conducted mainly with the use of these robots. An AUV is pre-programmed with the task to be performed. It operates on batteries, which means the tether is not needed. It does not need a surface vessel to run along behind it, providing power and instructions. In various parts of the world, the oil fields are getting deeper and deeper. Close to hand in Malaysia, they're at depths ranging down to 1,200 meters. But 200 miles southwest of New Orleans in the Gulf of Mexico, Shell have an oil field called Stones in 2,900 meters of water. In depths like this for routine tasks, AUVs are more suitable than ROVs. An extreme new AUV is called the Ilium. This has been developed between Kongsberg and Equinor. It's built in sections like a centipede and can swim through the water, bend and look underneath objects such as templates on the seafloor. It can also operate valves when used in segmented mode. When tracking pipelines, it becomes torpedo-shaped for ease of movement through the water. And it can also be used in a U-shape to video and examine both sides of a pipeline at the same time as it swims along. The Ilium lives in an underwater garage where it recharges and uploads the data it's acquired on its last mission. By working in this way, it minimizes the need for large support vessels, thus cutting fuel and personnel costs. It minimizes the time taken for launch and recovery to get to the job and increases working time on the seafloor. They can inspect wellheads and pipelines, detect leaks, and open and close valves. Another new development is the AUV that can turn into an ROV in a few minutes, and one such example is called the Aquanaut. This was developed by scientists and engineers that all worked for NASA. This gives it the ability to travel at speeds of up to 6 knots, which means fast transit times and a high-speed survey ability. It has a long-endurance battery power pack and is equipped with very high-tech manipulators, making it dexterous for delicate tasks. These new manipulators can also be equipped with force feedback. This means it's actually possible to pick up an egg or zip up a bag. When it reaches the location of the task to be performed, requiring its ROV abilities, the Aquanaut transforms from AUV to ROV. Here we can see it taking tools from its tool rack. In its holding position. Then when it's finished, it transforms back into an AUV. Neither of these robots, sophisticated though they are, can carry out all the repairs that may be necessary subsea. The splash zone. This is the area on an offshore platform that needs the most inspection and repair work. This is because it's the area where salt water and oxygen mix on the steel of a structure, causing the most corrosion. It's also the area where flotsam and jetsam impact the structure, and occasionally vessels do as well. It's the area where the coating comes off the quickest. That obviously means that the surface of the steel is exposed Therefore, the corrosion and rusting happen. It is the most challenging area to work in. Here is a look at some of the tools that are currently available for work in the splash zone. Some of the problems with inspection and repair in this area are the size of the waves. Off Norway, waves of 25 meters have been recorded. We're on the 7th floor of this building. 25 meters equates to a building of 8 stories high. In Thailand, 2 meters is common. The rise and fall of the tide is another problem. In some places, this is as much as 15 meters. Here, it's generally about 2. And then there is the current. In Thailand, in general, it's about half a knot. But in other parts of the world, it can be 4 to 5 knots. All of this, when mixed with the locations of the boat landings, the conductors, and the risers on the structure, and the hazards of fishing line and rope entanglement. All these make work with divers or ROVs incredibly risky and dangerous. To perform actual work in this area is almost impossible, and yet this is where the work is most needed. In this video, you see examples of existing robot technology. As well as everything we've just mentioned, is the location of the area that needs repair and inspection, which is at sea level. This can be 30 meters below the main platform deck. To get here traditionally is by rope access. To be able to work here, the robot needs to be able to cling on to the structure or the pipe that needs inspecting. Here we can see the swells, and this is a calm day off Denmark. It needs to be able to cling on hard enough not to be knocked off by a wave or washed off by the current. It would seem easy to surmount this problem for a robot that has arms wrapped around the pipe. However, the risers are attached to the structure by clamps. And in order to be able to climb down the pipe, the robot needs to be able to move past this clamp. This involves a method to hold on with one arm and with the other arm reach around the clamp to hold on the other side before you let go with your first arm. This can all be done, but then there is a restriction on the weight of the robot that can hang on to a pipe to consider. And the area of operation that we're working in is called Zone 2, which means that the robot needs to be certified to work in an area where gas could be present that may be ignited. And in addition to taking video and photos and corrosion readings, maybe laser scanning or weld crack detection is needed. If problems are found, then some form of repair needs to be carried out. And this is where current robotics come up short. There are almost no robots today that can repair risers, conductors, or members. The most common repairs undertaken at present are the installation of clamps. This is normally performed on a horizontal pipeline. A rough costing for an ROV installed clamp on a pipeline would be in the range of $7 to $10 million, depending on the pipeline size, pressure, the length, and the depth below water of the repair that's needed. Today, it's not possible to put a clamp on a vertical pipe, such as a riser, robotically. Another technique in common use is wrapping the area with a suitable tape that may protect from further corrosion, or it might be used to strengthen the pipe to reinstate it to its original working pressure. Before the tape can be applied, the area needs to be thoroughly cleaned so that the tape will adhere. Should there be holes in the pipe, then these need to be covered before the tape is applied. And finally, it may be necessary to apply many layers of tape for pressure containment. 12 wraps are not unusual. 12 wraps give 24 layers because each wrap is overlapped by 50%. If we take an example of a 36-inch pipe and we want to wrap 2 meters of pipe, the robot needs to be able to carry 1,750 meters of tape. That's a mile of tape to perform a 2-meter repair. This means that the robot needs to hold this much tape, be able to wrap it, and be able to join the tape rolls together. This is the sort of extreme robotics that are needed offshore. Purely inspection-related abilities are no longer enough. As oil and gas facilities age, they need repair. This is driving the demand for ever better and more sophisticated robots. When a lot of these fields were installed, they had a lifespan of 30 years. But because of the drive for a cleaner environment, and because we've been better at extracting the oil, the 30 years is up and the fields are not dry. So the oil companies want to extend the life of lots of these platforms. And that means that the repairs, the corrosion have to be stopped, they have to be repaired. Pipes that are corroded need to be brought back to their original working specifications. But robots alone, however, are not the answer. Methods of repair have to change. If we take the wrapping scenario, the resins used in the tapes have a setting time of about 30 minutes before they become too hard to use. For robotic application, this isn't enough time because the robot has to be able to go from the surface down to the area of the repair, then it has to clean it, and then it has to start wrapping. So this isn't enough time. And the answer is that a new method needs to be found. Then a simpler robot could be used. Other extreme uses. Well, one of the ways that we join things together and repair things normally in the day-to-day world is by welding. So if we could get a robot that's pre-programmed to be able to undertake welded repairs on a pipeline or platform member, then that would be one of the answers. Because these automatic welding machines already exist. It's now a matter of adapting the technology to be able to perform these tasks subsea and robotically. Painted repairs. It's far easier to paint something than it is to wrap it. And paints are already regarded as being able to give you a 15-year life. Why can't we paint these areas? We're doing it on oil tanks, so now we need to miniaturize the technology and develop new paints that can be applied in the areas we want them. Lots of stuff gets thrown overboard from a platform in its life. And this needs to be able to be removed. In the renewable industry, it's now a requirement that the structures are inspected every year for the first 3 years. To do that, they have to be cleaned and inspected. Today, that's done with a vessel and either an ROV or divers, and it takes a lot of time. That vessel costs a lot of money. Why can't we have something like the vacuum cleaner that we see in the shops now, that's remote controlled, that goes back to its charging station? We could have an ROV or AUV like that that goes out and does it. Firefighting is another area. And the demand for better robots that can actually solve and repair problems will only grow, together with the technology that will enable these robots to perform these tasks. Here we see the awful scene of a fire on a platform. we wouldn't really like to have to put men on there to fight that if there was an alternative. Here we see an alternative. These could be installed on all the platforms. They have their own water curtain, cameras, gas sensors, fire monitors, and obstacle avoidance systems. So as we move forward, there are many new developments on the horizon that are going to make more extreme robotics easier. The ability of computer chips to store more information is big, because with that comes the ability for the artificial intelligence of robots to increase. In order for AUVs to be able to travel further distances, you need to have better batteries. And every day, these are being improved. They're getting smaller and lighter, which is ideal for robotics. Today, we recharge batteries with solar power or by plugging them into the mains. But there's a Korean company that has now developed a way to recharge your telephone through a Wi-Fi signal. It won't be long now before that's a new ability. Then we've got materials like graphene, which has just been invented. It's lightweight, very thin, and extremely strong. This is a game changer because it means that robots can be smaller, lighter, and stronger. Acoustic data transmission is something that today is quite difficult because the sea is very, very noisy. Apart from ships and boats, you've got irritating little things like prawns that make a terrible noise underwater. And you have to cut out all that background noise in order to be able to hear the signal that you're trying to hear. But this is becoming more and more possible. And that means that you won't need to dock your AUV in its garage to upload or download data. You'll be able to talk to it while it's swimming along in the water. Artificial intelligence is increasing every year. And this will enable new robots to make more complex decisions on what actions to take when they come to a problem. And of course, education. And that's what's so lovely tonight, is to see that there are so many of you here from the universities that have come to hear a little bit about robotics. Thailand has always done very well in robotic challenges. So as a conclusion, when we look at what we're capable of doing as humans, apart from bombing each other to bits, look at NASA and its Mars rover, with the helicopter Ingenuity flying on the surface of Mars, where signals take hours to get there and back. Look at the new James Webb telescope and the way that was built in so many pieces, and it's been unfolded and it's back in position and it's working. That's an incredible thing to be able to do. The feats that we can achieve are truly amazing. It makes me sure there's a great deal more that can be done here on Earth, even in the challenging realm of the offshore marine environment, which after all covers so much of our planet. Thank you. Look, far too quick, was it?
Sorry. Any question from the floor? Student first, priority. Just think of one ครับ What is robot?
Hello, my name is Pakorn Bunpesh. I'm at the third year mechanical engineering from Chulalongkorn University, and my interest field is robotics too. So not only in AI and machine learning, I also interest in material science too. So I would like to ask you, which is the most important material for offshore extreme robot in the development.
Today, most
Yes.
of the ones that you've seen are made from aluminium, normally,
Yes.
steel, and carbon fiber and glass fiber.
Yes.
When we looked at the splash zone, all those robots that currently exist in Europe, which seems to be where they're saying is the center of excellence for it, weigh like 1.5 to 2.5 tons. That's a huge weight. You have to be able to get these robots to the right place. You have to be able to launch them and put them on the place they need to be. So weight is a major thing. So today, there's plastics such as Delrin, which we believe can be used. And you can cut the weight of the robot. There was one you saw on there, a red one, that weighed 140 kilos. We've cut the weight of that from 140 to 40 kilos. We've cut 100 kilos off. So I think that going forward, materials like carbon fiber, this graphene, plastics, as well as in some places aluminium, will be what's used in the future. The main things with a robot is it needs to be simple, it needs to be strong, and it needs to be reliable. And some of the stuff you see used offshore today is really complicated, and people can't fix it. So you have to get foreigners over here to operate it. That's bad for the carbon emissions of the aeroplane flight. They then have to do 2 weeks in quarantine. Somebody's got to pay them. They're not going to do that for nothing. And you're not transferring knowledge to the local people. So robotics need to be simple.
Thank you.
A very long answer, I'm afraid.
Yes, thank you.
I'm Warapat from Chevron. Thank you, Simon, for the presentation. It's very impressive on the clip video and animation. My question is about the energy source of the robot. I do believe that they use battery and maybe can use the solar cell for the energy source for the small robot. But for the heavy duty robot, we need battery, but origin source of the energy mainly from the fossil. As today we have the escalate level of the carbon emission. If we escalate the level of the robot utilization to the mass level, it may be the concern on the carbon emission too. So what is your opinion of the robot development and the carbon emission?
Robots will definitely be battery operated more than anything else. That's got to be the future. And solar power is one way of doing it. This Wi-Fi ability to recharge batteries, I think, is very, very exciting. And I think it must be possible also by transmission of waves subsea to be also able to form some way of recharging batteries. It's something I'm not familiar with now, but it has to be possible because sound subsea can travel for hundreds of miles. I remember when I was young yesterday, I worked with some submariners, and so we're talking in the 70s, and they told me that they could hear ships leaving New York Harbor from the southwest of England. So that's how far sound can travel subsea. There must be a way of using that to be able to recharge batteries. Everything is driven by demand, and it's going to take money. So when somebody decides that they want to invest in something new, then maybe that's one of the things that will be looked at.
So you mean that utilize the robot will not impact the carbon emission? Or I'm not clear about the answer. Because I do believe that the origin source of
Yes.
is the fossil mainly.
But I think you have two different things. you have today, let's say, you're charging your batteries by your telephone by plugging it into the electricity supply, which is bad for your CO2 emissions. If you had a solar panel, you could plug it into that, and then you could recharge your battery from solar power, which would get around the CO2 emissions. If we could use solar power to power an energy source, subsea, that transmits, let's call them acoustic waves, to a receiver, like you have a speaker on a musical system, it vibrates, and you take those vibrations and you harness those into a charging system. So you're using your solar power to transmit noise, which is received and changed into electricity. That means your AUV could be able to operate forever underwater.
Thank you very much.
Any other questions? If no, let me ask one then. Hi, my name is Panit from Mubadala Petroleum. Actually, we discussed about this before the session. I think one of the key benefit of extreme robot or robot here is to replace the dangerous tasks that has been done by human before, especially diving operation. So in your view, what are still the gap between the human maneuver comparing to the ROV or robotics approach?
The biggest thing for us is the ability to feel. Now you've got these manipulators with force feedback abilities, so you can pick up an egg or zip up a bag. But also the ability, when we're diving, to do the wrapping, for example, of a 36-inch pipe. You can't get your arms around it, but you can use two people together. So one person is on one side, one is on the other. So with an ROV, that's also difficult. So you need to make something that's a frame that goes around the pipe that can pass your tape around. So we have to be able to look at what humans do and make robotics similar to the aquanaut that we saw, that can go in one form and transform themselves into something else when they get to the job that needs to be done. And of course, there's the ability of humans generally to, unless they've had too much to drink, to think of the right solution for something. So humans have that ability to think, whereas AUVs have to be pre-programmed.
Thank you very much. I don't think you have too much drinking, but anyway. Any other question from the floor ครับ If 1, 2, 3, yes. If no more question, then thank you very much, Kun Simon.
Thank you all very much indeed.
Photo. Thank you, President. For the upcoming SPE Thailand section meeting, so as Kun Kasian mentioned, we have massive event in May, on 19th of May by Dr. Saravut Keotatip on the topic of Thailand upstream activity insight. This will be our SPE industry reception as well. Hope to see all of you there. I'm not sure if you're aware of this, but it has been terminated. So basically, there was an approach that AAPG and SPE are under consideration to merge, but it seems that that decision has been deferred. Sure, if it has anything to do with the ongoing war or oil price, but anyway, basically, it's not on the table for now. Okay, for the upcoming event, we have the IADC SPE Asia Pacific Drink Technology Conference from 9 to 10 of August this year in Thailand. So now they are open for paper. You can also check out other SPE Asia Pacific upcoming event from www.spe.org/Asia Pacific. And you can see many upcoming events this year. Of course, there are several ways to reach us. You can go to our official website, www.thaisp.org, where you can find the upcoming event, new announcement, young professional, student scholarship, online webinar, and many more. You can follow our Facebook. Simply pick up your phone and take a QR code here. You can also follow our LinkedIn group, and last but not least, we already have a Line official. So if you have any question or anything, you can also chat with us and reach out in several channels. And here are the lucky draw. Where is the ball? May I have Kun Simon on the stage. Pick up the lucky one. So the prize today would be the very beautiful, expensive, gorgeous pen. Picking up by the man who tried to open it. He can open it now.
Glasses on.
Okay, who is the lucky?
Kun Pawat from Chulalongkorn.
Oh, okay. See? Lucky student. Congratulations, Kap. Another one. The same or same color, ba?
Steve Boundy.
Congratulations, Kap.
You'll have to give me your winning formula.
Well, have three.
Thank you very much ขอบคุณครับ and congratulations to the winner. I understood we have serving you since 5 p.m. But if that hasn't been enough, then you can continue your journey at the ground floor at the Reservoirs bar, and we have a 2-for-1 promotion if you address that you are coming from a SPE event. See? That seemed to be louder than our sponsor, by the way. Okay, another round of applause from our sponsor for tonight. Thank you. And that's it. Have a good evening and hopefully see you down there. ขอบคุณครับ See you.